Welcome back. So here I've got my Raspberry Pi Pico. Here I've got a green LED and a red LED, and I've got two resistors. I believe these are either 220 ohms or 330 ohms for the Raspberry Pi Pico. I might show on screen quickly how to do the calculation to figure these out. So you have to do the voltage drop first, and a typical LED uses about 2 volts ish. Now you do have to check for different colors, but I'm just going to stick with 2 volts and use a higher rated LED just to make sure I'm okay. So again, I'm going to be connecting these individually to the Raspberry Pi Pico, and then I might at some point maybe link the temperature sensor to turn the LEDs on. So for example, if it's above 22 degrees, which is what I really like in the house, then the green LED should go on. But if it falls below that, then the red LED should go on. Simple system, but let's jump into it. This is going to be mainly aimed at people doing BTech Level 3 Engineering Unit 6 microcontrollers. There's a section on the exam where you have to choose your parts, your components, let's say. You have to justify why you've chosen to use components. So I'm going to do that section here for my system. I'm going to try and do it for every system I do in the future, so that people that are doing BTech Level 3 Engineering Unit 6 microcontrollers, they will have a better understanding of how to do that section. So we're going to have parts and justification, and down here we're going to have a Fritzing circuit diagram. Okay, so let's move that down. Parts and justification. Okay, the parts I'm going to be using, so let me do insert table, and I'll do that. Let's bring this over a bit more. I'm going to do red LED. I'm going to do 1 times, so that's just 1 for the quantity, 1 times green LED. I'm going to do 2 times, let me just say 330 ohms. That's probably the safest bet. And what else do I have? Raspberry Pi Pico microcontroller. What else do I need? OHMS. I don't believe I need anything else. I'm going to leave out the temperature sensor for now because that's built in, but it would be the same thing. Simply just add another component. But because I'm not going to actually connect it to anything, I'm going to leave it out for this one. So component and justifications. Let me make another one. Let me cut this, move it down. This is going to be component and justification. Right. What is first? Red LED. Why do I need a red LED? This is going to be a visual aid. This is to act as a visual aid to show that the system is doing one of the pre-programmed actions. For my system, the temperature controls the red LED to go on when the temperature falls below a certain value. I'm not going to type out all of this again, but simply put, the green LED is going to do the complete opposite. So I'm just going to cheat. You should definitely write out the whole thing, especially in the exam. But I'm just going to say opposite of red LED. I'm going to leave it as that just so I can move a bit quicker. Resistors. Why do we need resistors? Resistors limit the amount of current or voltage going into a device. Limits or reduces the amount of current going through a device in order to keep it safe. Yeah, that's typically what resistors are for, and LEDs need a resistor. Raspberry Pi Pico, cheap, low-powered, P-O-W-E-R-E-D, cheap, low-powered microcontroller, T-R-O-L-L-E-R, cheap, low-powered microcontroller with many GPIO pins, many programmable, general purpose input output is what GPIO means, many programmable GPIO pins, some with I2C, which is a communication standard, I2C, and what's the other one again? SPI. So it has both of these. I'm going to leave it as that for now. Now, it's a good idea to expand a bit more on this. But in the exam, every single component you have in your circuit, this is again for Unit 6 microcontrollers, every single thing you have in your circuit, you want to explain why you decided to choose that component. I've chosen the Raspberry Pi Pico because it's a cheap, low-powered microcontroller, many programmable general purpose input output pins, some with I2C and SPI communication communication, programmable, I spelled this earlier, using both Python and C. So it's going to be very popular. You know what? I'll leave it at that as that for now. The next thing I need to do is to do my fritzing diagram. So I'm going to paste my thing here and I'm going to fix this up. I'm going to put it on the website as well. But for now, I'm just going to paste my fritzing circuit diagram here. So let me now go to fritzing. I'm going to zoom out. I'm going to drag my Raspberry Pi Pico on here. I'm going to rotate it 90 degrees counterclockwise and put it at the very edge of my board. This is how I actually plug it in on my actual breadboard. So I'm going to do it the same. I'm going to go up to search. I'm going to search for LED. Quite a few of them come up. I'm going to grab a red one and a green one, or I'm just going to grab two red ones. Oh, 1 second. Leave it as that. And now I'm going to search for resistor, R-E-S-I-S-T-O-R. Resistor. This is a 220 ohm. Doesn't have any 330 ohms here. I'm going to grab a 220 ohm and see if I can actually change the value. Yep, there we go. In this property section here, you can change it to 330 ohms. So I'm going to remove where it says 220 and put 330. Whatever value resistor you have is completely fine. It doesn't really matter. You've done your calculations. You've worked out what you need. That's fine. I'm going to make a copy of this resistor as well, just so I have two of everything. So this is all I need for now. I'm going to now connect all of this so that I can make my circuit. But I know that I need to flip this around because there's a specific way I like my circuit to look. So I'm going to highlight both of these. I'm going to flip horizontal. So I'm going to have the anode and cathode the opposite way around. I'm going to use, okay, let's me do my ground volt first. So this one is going to be ground, goes down here. I don't need a positive because I'm going to be using the microcontroller pins itself to program this. But before I do that, a good idea would be to go Pi Pico Datasheet just to see what pins I'm going to be using. So you guys should 100% bring a datasheet into the exam with you. You're allowed to bring this into the exam. You need to know where the pins are. I'm going to zoom all the way in. Yeah, pins 17 and 16. So these two at the top, the very top ones. So if I go back to fritzing, I'm going to put one resistor there and put one resistor somewhere there as well. Oh, I need to change the color actually. So let's make the first one green. And the first one is going to be connected to here. So I'm going to connect that one there like so. And click on that. Go down to the properties again where it says color. I'm going to change this to green. Whichever green one you want is fine. I can put this one on the green here. I can put that top one on the red there. Now I'm trying to make this as neat as humanly possible. And this can go all the way down to the ground pin. This can go all the way down to the ground pin as well. Yeah, that looks pretty all right. Now, I would recommend that in the exam, you save multiple versions of your circuits. So I would go file save and then go file save as, just so you have multiple versions of it. I'm going to go file save, and I believe mine is going to be desktop. I have a folder called Raspberry Pi Pico How To, and I'm using now external LEDs. I'm going to call this one external LED, call it 01 for example, save. But how do I get this into my Word document? There are a few ways I can do this. I can do Windows flag on my keyboard, hold it down, press and hold shift and tap S. This screenshot thing comes up and I can do this. I highlight the area I want. I go back to my Word document and I can paste it. This way works perfectly fine. This is definitely neat enough. You could leave it like that, but the other way, if just in case you wanted to know the other way, you go back to fritzing, you go to file, you go to export, you go to as image, and you choose PNG. And I would save it in that same location and just click save. Now, when I go to that folder, which is in here, and I go to external LED, I'm going to have a PNG file, which is this one here. If I double click on it, it comes up with my entire circuit. Now I can drag and drop this into Microsoft Word and crop what I need. So either way you want to do it. So if I have Microsoft Word open, let me have Word open, which is here, and I have my folder here. I can simply drag, let me delete that one first. I can drag this across into Microsoft Word like so, and it will appear just like that. Or let me delete this again. I can go to insert, I can go to pictures, I can go to from this device, and I'm going to go desktop, and my folder I know is called Pico how to external LED. So browse to where you saved the image, right? And just click insert when you found it, and that's my image here. Again, whichever way you choose to do it is fine. I'm going to leave it as the screenshot method for now because that's probably the quickest method for most people, so you don't have to go file and export and all of that stuff. Leave it as that for now, and then I'm going to build the circuit in front of you guys on camera. So let's jump back over to the circuit board. Okay, so I've said that my Raspberry Pi needs to have the resistor coming from pin 16 and 17, I believe, so that one there. And I'm going to have it go into this one somewhere randomly over here. And same thing for the other resistor, going from the other pin, so that one there, maybe over to, let's say, pin 29 here. Now, you don't want these resistors touching. It's not going to be the end of the world, obviously, but ideally you want to have them separate. So as you can see, that first one goes from that pin 20 of the Raspberry Pi over to pin 27 of the breadboard. The second one goes from pin 19 over to pin 29, and that should be good. I'm going to now connect my green LED in the first one and bring that down to ground. So I'm going to go green LED onto that one there, then simply put it on the other side of the breadboard. Red LED, same thing. Let me just do this quickly. Then I'm gonna put that, let's say, there. Sorry guys, the old man eyes, they're failing me. Let's see if that works. All right, now let me get my screwdriver. Here I've got my resistor connected. Oh, see, I even did it wrong. It's not even in the same section. See, old man eyes, guys, old man eyes. Just bring that over one. That should be good now. So now I have that resistor going from the Raspberry Pi Pico, going all the way down to this one here, and I'm going to put this into ground. I have the other resistor going into the red LED, and that's going to go to ground as well. How do I add ground? I think pin 3 on this is ground, and again, you should be checking your data sheets all the time just to make sure. Actually, no, I'm going to do it this way instead. So I'll have that one go there. Oh, what did I do? And I'll have the other one go down as well. Now I need to now link a ground pin, so I just have a piece of black wire here. I prefer to use black for ground and red for live, but it really doesn't matter. No wire colors matter. It's entirely up to you, the person who's making the circuit. So I'm going to cut this, strip the other side as well if I can. Oh, always get that wrong. Here we go. Strip the other side, and I'm going to go from pin 3 into the very bottom one. That's going to be where ground is. And I believe that's it. So pin 3 there goes into ground, and these LEDs go into ground as well, and they also go from the resistors, and the resistors come from the Raspberry Pi Pico. So it's now time for me to program this entire system. So I'm going to plug back into the PC and continue from there. Okay, so now I'm back on the PC, and I've already written a mini program here. So again, I do from machine import pin because I'm going to be making use of the pin libraries. I need to connect devices. In this case, my green LED, my red LED, my resistors to the pins of the Raspberry Pi Pico. I say import U time. I will be sleeping at some point, so pausing the program at some point. Now, this is where you're going to need to make sure you have your datasheet documentation ready. Let me zoom in as far as I can, scroll across, 1 second. I have here my Raspberry Pi Pico. I'm saying green LED, which is that one there, is connected to the very first pin at the top. So if I come here and I look at the very first pin at the top, it's actually pin 21, but it's a GPIO 16. So that's why in my code I've got pin 16, because that's the one I'm allowed to program. My red LED is connected to the second one at the top, the one just after it. So my red LED is connected to pin 22, but it's actually GPIO 17. So when I come back here, that's why I've got pin 17. So my green LED again goes to pin 16 and it's an output pin. So I say pin.out. My red LED goes to pin 17 and it's an output pin. So I say pin.out as well. All I've done here, I've said green LED high, red LED high. It's just going to turn them on and leave them on. That's all it's going to do. You know what? I can do toggle as well. I might as well do toggle so I can turn them off again. Toggle, I believe. Let's copy that. Put that here. So now when I run my program, I should ideally have both LEDs coming on at some point. And then when I run it again, both LEDs should go off. So I'm going to press F5 on my keyboard. Pay attention to both the green and the red LED. If I've connected everything okay and everything's working fine, they should turn on. So I'm going to press F5 now. There we go. Both LEDs are on. Hopefully you can see that. I'm going to press F5 again. Both LEDs are off. Press F5 again, both LEDs come on. Press F5 again, both LEDs go off. Now I'm going to leave this one here for now. If you guys want to toggle the LEDs so they flash, you already know how to do that. That was like the first program we did. So you can edit this one. I will put this on the website as well. I'll probably get around to doing it myself anyway. But you guys can go and edit this one and make it toggle the way you want. What I'm going to do in the next one is maybe have the temperature sensor controlling both of these. I'll leave this where it is for now just so you can see how to connect external LEDs and how to use them as well. And thanks for watching.